vectors. In that, today we will going to see the solved examples on collinearity and coplanarity of the vectors. Now, example first, state the vectors which are equal in magnitude, parallel in the same direction, equal, negative of one another. Now here, this look at these figures. This A bar and C bar have the same length. So there, as they are having the same length, so the magnitude is same. Now let us think of their direction. Now A bar and B bar having opposite direction. Okay, so these are the negatives of one another. Again, B bar and D bar, they are also having this, they are uh, not having the same direction, and also length is somewhat different. Now look at the first, equal in magnitude. So what is the this A bar, C bar and E bar? If we see them, their magnitudes are same because they are having same length. Then parallel. Now this A bar is parallel to B bar, is parallel to C bar, is parallel to D bar, but E bar is not parallel to any one of these. So A bar, B bar, C bar, D bar, these four vectors are parallel to each other. Now in the same direction, B bar is in this direction and E bar is also in the same direction. So A bar and B bar having the same direction, whereas C bar and D bar having the same direction. Now which are the equal vectors? This A bar equal means the vectors which are having same magnitude and same direction, that vectors are said to be equal. So here no vectors are equal. Then fifth one, negative of one another. This A bar is negative to C bar and this B bar is a negative of D bar because they are in opposite direction. Next, in the diagram, KL bar, L bar is equal to A bar, N bar is equal to B bar, M bar is equal to C bar, T bar is equal to D bar. Then we have to find A bar, B bar, C bar, D bar. Using these vectors, we have to find in terms of these vectors LT bar, KM bar, TN bar and MT bar. Now in triangle KTL, look at this triangle KTL using the triangle law. What is the triangle law? This KL can be KL plus LT is nothing but KT. So KL plus LT is KT. Putting those values of KL bar is A bar and KT bar is D bar, we get LT bar is equal to D bar minus A bar, the first one. Now we want to find KM bar. KM bar. So we will go for which a triangle? You will go for polygonal law of triangle. Now KM bar is the same as KL bar plus LN bar plus NM bar. Okay, so and put the values A bar, B bar and C bar. So I will get this KM bar as A bar plus B bar plus C bar. Now next, this TN bar, TN bar. So to find TN bar, we will use again polygonal law. TN bar is can be written as T K bar, K L bar and L N bar. But TK bar is minus D bar, KL bar is A bar and LN bar is B bar. So we get TN bar as A bar plus B bar minus D bar. And the fourth one is MT bar, MT bar. Now to find MT bar using polygonal law of vector addition, we get MT bar can be written as MN bar plus NL bar plus k bar plus k t bar, we get mt bar. Now what is mn bar? It is c bar minus c bar. What is nl bar? It is minus b bar. What is lk bar? It is minus a bar. And what is kt bar? It is d bar. So we get the resultant as d bar minus a bar minus b bar minus c bar. Now the next example is find the magnitude of the following vectors. A bar is I minus 2 I cap minus 2j cap plus 4k cap. B bar is equal to 4i cap minus 3j cap minus 7k cap. A vector with initial point 1 minus 3 4 and the terminal point 1 0 minus 1. Now we want to find the magnitude of the vectors. Now what is the A? A is I cap minus 2j plus 4k. So what is its magnitude? Its magnitude is given by modulus of A bar is root a square plus b square plus c square. So root of 1 square minus plus minus 2 square plus 4 square. So 1 plus 4 plus 16 is root 21. This is the magnitude of a bar. Similarly, we can find the magnitude of b bar. So 4 square plus minus 3 square plus minus 7 square. Now, in third example, the initial point is given and terminal point is given. So A is given and B is given. So we have to find the vector. Okay, vector AB bar. Now vector AB bar is given by B bar minus A bar. You know that the position vector AB bar is position vector of B minus position vector of A. The position vector of the second point minus position vector of the first point. So 1 minus 1 is 0. 0 minus of minus 3 is plus 3 and minus 1 minus 4 is minus 5. So this is the vector AB bar. Then magnitude is given by square root of 0 square plus 3 square plus minus 5 square. So this is the magnitude of the given vector. Then A, B, C, D are the 4 points in the Cartesian plane. We have to find AB bar and CD bar. It is so simple. As A is 2 3, so A bar is 2i plus 3j. B is minus 1 5, so B bar is minus I plus 5j. C bar is minus I plus j. D bar is minus 7i plus 5j are the 4 points in the Cartesian plane. So these are the position vectors of the given 4 points. Now we want to find AB bar. Now AB bar is the B bar minus A bar, position vector of the second point minus position vector of the first point. So by similarly we can find CD bar, position vector of D minus position vector of C. Okay. Then in second we have to check whether CD bar is parallel to AB bar or not. Where CD bar is minus 6i plus 4j, you can take 2 common. So whatever the remaining term is minus 3i plus 2j, it is nothing but your AB bar. So here this first vector is a scalar multiple of the other vector and hence we can say that they are parallel. The third, E is the point K1 and AC bar is parallel to BE bar. Then we have to find the value of K. Now E, the position vector of the point E is Ki plus J. So BE bar is E bar minus B bar. What is E bar? It is A Ki plus J. What is B bar? Minus I plus 5J. Take their subtraction. You get K plus 1I minus 4J. Now it is given that BE bar and AC bar are parallel. As the vectors AC bar and BE bar are parallel, they must be scalar multiples of each other. So K plus 1i cap minus 4j cap is equal to m times minus 3i minus 2j cap for some m. So multiplied by m, then K plus 1 is equal to minus 3m and minus 4 is equal to minus 2m. So from this equation I will get the value of m. I will put that value in this equation. I will get k as minus 7. Okay, so this is the value of k. Next, determine the value of c that satisfies modulus of c u bar is equal to 3 and u bar is equal to I plus 2j plus 3k. Now it is given that the magnitude of the vector c u bar is 3. So c times u bar is nothing but I will multiply this u bar by c, and so then I will get c u bar is c I cap plus 2 c j cap plus 3 c k cap, and then I will find its magnitude. So square root of c square plus 2c square plus 3c square. So simplifying, you get the value of c as root 14 c. So c is equal to plus minus 3 upon root 14. Find the unit vector in the direction of u bar and in the opposite direction of u bar, where u bar is at I cap plus 3j cap minus k cap. Now what is u? U is given, then its magnitude, we can find magnitude. Okay, then how to find the unit vector in the direction of the given vector? We will divide given vector by its magnitude so that we get the unit vector in the direction of the given vector. So this is the vector which is in the same direction as that of u bar and it is a unit vector. So is then the opposite direction of u bar, so just simply give the minus sign to this vector, you will get the unit vector which will be the opposite to the given vector. Next, show that the vector are parallel. We have to show that these two vectors are parallel. Now let a bar is the first vector, b bar is the second vector. Now if you see, this b bar can be written as a scalar multiple of a bar. That means a vector is a scalar multiple of the other. So they are parallel. The non-zero vectors a bar and b bar are collinear. Find the value of lambda and mu. Now a bar plus 3b bar is equal to 2 lambda a bar plus mu b bar is given. So if I equate when we say that the two vectors are equal, their corresponding components must be same. So here a bar and here a bar, so 2 lambda must be equal to 1 minus mu must be equal to 3. So lambda is equal to 1 by 2 and mu is equal to minus 3. Similarly, from second equation, mu is equal to 1 plus lambda and 2 lambda is equal to 4 mu. So after solving, what we get, lambda is equal to 2 mu. I will put that in this equation, lambda is equal to 2 mu. So 2 mu is equal to mu. So 1 mu is remain and you get mu is minus 1. You will put that minus 1 in the second equation, you get lambda is equal to minus 2. Similarly, we can find the value of lambda and mu from the third equation. Are the following set of vectors linearly independent? We have to check whether the given vectors are linearly independent or not. Linearly independent means their linear combination is 0 but the scalars are not 0. A bar is given, b bar is given. So b bar is equal to, we can write b bar as a scalar multiple of a bar. So 3a bar minus b bar is equal to 0. So here a bar and b bar are linearly independent vectors because their 3a bar minus b bar is equal to 0 means their linear combination is 0 but the coefficients x and y are non-zero. Here a bar and b bar are collinear. Now second example, a is given, b is given, c is given. So let x a bar plus y b bar plus z c bar is equal to 0. Put the first vector, second vector and third vector in this equation. Multiply first vector by x, second vector by y, third vector by z. Then collecting the coefficients of I cap, coefficients of j cap and coefficients of k cap. We will get the now then after you will equate the coefficients. Here coefficient of x and here the coefficient of, here 0 bar means 0 I plus 0 j plus 0 k. So minus 2x plus y plus z is equal to 0. 0 x minus 2y plus minus 4z is equal to 0. And the third one is minus 4x minus y plus 3z is equal to 0. Now if you see these two equations and if we solve these three equations, definitely we will get the x is equal to 0, y is equal to 0, z is equal to 0. That means their linear combination is equal to 0 and the vector and the coefficient and the scalars are 0. That means the vectors are linearly independent and a bar, hence a bar, b bar, c bar are non-coplanar. This is the 10th example. A bar is given and B bar is given, and we have to find the modulus of A bar, then A bar plus B bar, A bar minus B bar, 3B bar, 2A bar plus 5B bar. A bar is given, so we can find its magnitude, root A square plus B square plus C square. Then we can find A bar plus B bar, this component wise addition. I component, I component, pick the sum of I component, then JJ component and KK component. Similarly, difference for taking the difference of the two vectors, the again difference of I component, JJ component and KK component. Now 3B bar means we have to multiply the B bar by 3 only, and 2A bar plus 5 bar means we have to multiply the first vector A bar by 2, and then we will add it to the vector second vector multiplied by 5. What is the distance of the point 3, 2, 3, 4 to the xy plane? Now we want to find the distance of this point in space. This is the point in space to the xy plane. Now the distance of the point from xy planes is nothing but its z coordinate, modulus of the z coordinate. Similarly, distance of the point from x-axis is nothing but the yz plane is nothing but the modulus of the x coordinate. Similarly, distance of the x point from the xz plane is nothing but the distance of the modulus of the y coordinate. Now, distance of the point from x-axis is nothing but square root of y square plus z square. Similarly, distance of the point from y-axis is nothing but root x square plus z square. Now that we want to find the distance of the point from the origin, so we will use root x square plus y square plus z square. And finally, to find the distance between the 2 points, we will use the formula x2 minus x1 bracket square root of x2 minus x1 bracket square plus y2 minus y1 bracket square plus z2 minus z1 bracket square. So 2 minus 2, 2 minus of minus 2, 3 minus 7 and 4 minus 3 to get the distance between these two points. So we get it to be root 33 units. Now the next example is prove that the line segment joining the midpoints of the two sides of the triangle are parallel to and half of the third side. This is the figure. Let the triangle be ABC. We are considering the triangle ABC. M and N are the midpoints of the sides AB and AC respectively. Then AM is 1/2 times AB bar and AN bar is equal to 1/2 times AC bar. Now using the triangle law, AN bar is equal to AM bar plus MN bar. So MN bar is equal to AN bar minus AM bar. So what is the value of AN and AM? We will put that values 1/2 AC bar minus 1/2 AB bar. 1/2 okay. So this MN bar is equal to 1/2 AC bar is as it is, but this AB bar I have written BA bar. So we know that AB bar is minus BA bar. Similarly, AB bar is minus BA bar. So this minus becomes plus and 1/2 is taken away. So 1/2 BA bar plus AC bar. But BA bar plus AC bar using triangle law. BA bar plus AC bar using triangle law, we get it is BC bar. So MN bar is equal to 1/2 BC bar. So from this equation, we can conclude that MN bar is parallel to BC bar because it is a scalar multiple. MN bar is a scalar multiple of BC bar. Also, as they are equal, so they are scalar multiples of each other. So they are parallel, and this 1/2 says that this MN is 1/2 times BC bar. So BC bar is double than that of MN bar. In quadrilateral ABCD, M and N are the midpoints of the diagonals AC and BD. These M and N are midpoints of AC and BD respectively. Then we have to prove that AB bar, A B bar plus A D bar plus C B bar plus C D bar is equal to 4 MN bar. Now using parallelogram law, polygonal law of vectors, we get A B bar is equal to A B bar is equal to A M bar plus M N bar plus N B bar. Equation number 1. Similarly, A D bar is equal to A M bar plus M N bar plus N D bar. Similarly, C B bar is equal to C M bar M N bar plus N B bar. Okay, then finally C D bar is equal to C M bar plus M N bar plus N D bar. Now we will add these four equations together. Okay, so then we will get this equation, and in this A M bar and A M bar is 2 A M bar. Okay, M N bar M N bar M N bar M N bar is 4 M N bar. N B bar N B bar N D bar N D bar C M bar C M bar. So collecting the like terms together, we get twice AM plus CM plus 4MN bar plus 2NB plus ND. Now AM bar plus CM bar, A M bar plus M C M bar. So these vectors are in opposite direction. AM bar is opposite to CM because A M bar and this is C M bar. But M is the midpoint of this AC. So they are in opposite. The vectors are in equal magnitude but in opposite direction. So they will cancel each other. You get 0 here and 0 here. So only the remaining part is only 4 MN bar. So we get the required solution. AB bar plus AD bar plus CB bar plus CD bar is equal to 4 MN bar as required. The next example is expressed I bar minus 3j bar 3j cap plus 4j as a linear combination of these three vectors. We have to express this as a linear combination of this. So let R bar ज्या वेक्टरला लिनियर कॉम्बिनेशन मध्ये एक्सप्रेस करायचंय त्याला आर बार म्हणायचं आणि ज्यांच्यामध्ये एक्सप्रेस करायचंय त्यांना ए बार बी बार सी बार. So we have to show that R bar is equal to x a bar plus y b bar plus z c bar. Put the corresponding vectors in this. Multiply by first vector by x, second vector by y, third vector by z, collecting the coefficients of I cap, j cap, k cap, then equating the two vectors. Now equality of the vectors, I coefficient of I cap, component of I cap must be equal to the component of I cap. So we get three equations. So solving by Cramer's rule, by inversion method, by reduction method, any method that you know, okay, we get x is equal to 2, y is equal to 2 and z is equal to 3. That means we have expressed this given vector using the vectors a bar, b bar and c bar. Now show that the 3 points a minus 2 3 1 minus 2 3 b 2 3 minus 4 and c are collinear. We have to show that these 3 points are collinear. Let a bar is the position vector of the first point, b bar is the position vector of the second point and c bar is the position vector of the third point. Then we will find ab bar is the b bar minus a bar. Similarly, I will find ac bar, c bar minus a bar, and I will look at these two vectors. If you see, these vectors are AB bar is minus AC bar or AC bar is minus AB bar. So they are scalar multiples of each other. So AC bar and AB bar are parallel. The vectors are parallel, but they are having one point in common, A. So not only the vectors are collinear, but the points A, B, C are collinear. The next example is show that the vectors 4i plus 13j minus 18k, I minus 2j plus 3k and 2i plus 3j minus 4k are coplanar. They have to show they are coplanar. Let a bar is equal to the first vector, b bar is equal to the second vector, and c bar is equal to the third vector. Then you have to consider a bar is equal to mb bar plus nc bar. So a bar is a scalar multiple of b bar and c bar. Write a bar m times b bar plus n times c bar. So a bar is equal to this, multiply the first vector by m and the second vector by n and simplify, you get the three equations. Now solving first two equations, we get m is equal to minus 2 and n is equal to 3, and these two values satisfies the third equation also. So there exist the two scalars m and n such that a bar is a linear combination of b bar and c bar. Hence a bar, b bar and c bar are coplanar. Okay, now we will stop here.